Hello, hi, and welcome to our weekly podcast on senior versus junior developer. We'll be doing such live events quite often now. And the topic for today is how do we debug issues in production. But before going ahead, let's take a moment to introduce ourselves. I'm Mohit Yadav, and I teach at Scala. I've been a part of engineering teams at Hotstar and Nutanix. I was a senior developer in both the teams, and I let Pragya introduce himself as well.
Right, so I am Pragy. You might have seen me on the Skiller YouTube channel quite a lot. And I have been working I had worked at Directi in the past, Media.net branch of it. And since the past couple of years, I have been a senior software engineer here at Scala. So nice to meet you, everyone. I think we can begin it now.
Uh, so let me set the premise, right, or what this session is about, and how we are going to be running this session, right? We'll the starting in the beginning of the session we will give you the entire glimpse of how do you debug an application in the production environment, and then we'll give you a chance to ask live questions, right? So keep your questions ready. We'll give you ample amount of time at the end to ask questions. So the premise goes like this. Uh, let's say you have built a paid application that is supposed to stream live cricket matches. Now the match starts at 8 p.m. and 5 minutes into the game, your social media teams comes up to you and says that hey, lot of paid customers are complaining about poor experience on social media, right? They might be ranting about it, on Twitter or maybe Facebook groups or maybe tons of other places to rant about, right? Now, as an engineer who is responsible for streaming this match live to millions of users worldwide, what would be your next steps? I let Pragya talk about the three pieces that we can solve for, and then we'll get started. Pragya, over to you.
Yes. So if you look at any large scale application, right, any web service, anything like Google or Amazon or any sort of cricket streaming website that you see, you usually can divide the entire thing into three parts. Right. One is what you have is the client side, right? That is the actual user that is sitting there, and I mean they are streaming some let's say cricket matches. Right. The user has their browser, they have their browser cache, they are talking to a DNS, and so on and so forth. Apart from that, you have something called the infrastructure, right? And that is basically where your code is running. So perhaps let's say the website is deployed on something like AWS. So the infrastructure in that case will be the AWS web servers, right? On which your entire code will be running. Everything, the load balancer, the app servers will be over there. And the final side, the last piece of the puzzle for us is the server side. Right? By the server side, I mean that the actual code that is running on the infrastructure. Right? So the actual code that you have written, perhaps in the language using Java, perhaps using a framework like Spring Boot, right? That is what we are talking about. That is the server side. Now, out of these three pieces, we won't really be talking about the client and infrastructure in today's session. Right? We'll be focusing particularly on the server side. That suppose that you have figured out that the problem is not on the client side and neither in the infrastructure. The problem is at an API level. Then how do you debug it in production? Right. So one thing that we can say is, let us suppose that we wish to figure out that what exactly is the problem that our users are facing. Right. So one thing that we could say is that, I mean, let's say that I was on call on the duty. Right. So what I would like to do is I would like to ask our users, right, to report their problems via Twitter messages. So I would ask the users that, hey, just send me a Twitter message, just send us a Twitter message, and basically we'll try to figure out what the problem is and proceed from there. So how does that sound?
I think that sounds good, but there are few problems with it, right?
Okay.
Like you're collecting the feedback that is outside the realm of your application, and that might lead to what we call as a snowball effect. Now, what is a snowball effect? If you notice at avalanche, it starts from a snow which starts rolling down, and sooner or later it becomes an avalanche if there is enough snowfall, right? The same behavior we see in the like application side as well. The more people read it, the more negative publicity your application will get, and eventually people who are getting even a decent stream will start complaining. For example, a person who is supposed to get maybe a 720p kind of a resolution is getting a lower resolution, maybe around 320p or 480p, which is still manageable. They'll also start feeling left out, and they'll also start ranting about your application on Twitter, which is not an ideal case for any any business. So can we do something to contain this fire within the realm of your application?
Fair enough. So we don't really want to publicize this issue. So Twitter messages are a no-go in that case. So what we could do is while designing our application itself, right? While designing the application, what we could have is we could have some sort of a support infrastructure, some sort of support feature inbuilt with our application. Right. Once we have that, then the users can contact us via that support feature directly, and that will also help us to identify whether the problem is on our end or whether the problem is on the client end.
Oh, oh, that's great, man. I think you are also referring to if you have heard about Uber app support, right? They all they have is an in-app support. The benefit that we get out of it is like it contains the fire within the application. Plus, it will help us capture other insights as well, and like deeper insights like network speed, how much free memory was there in the application when this bug occurred, or is there a storage limitation on the client side due to which it is causing such issues. So we'll be able to dig deeper into the issue because a person who's just using your application might not be well have the entire context about the problem, and we can capture such problems using a client side SDK, and we can also use the same SDK to capture all any crash reports, and we can bundle these crash reports and send it to our backend servers, right? Many a
Fair
times
enough.
we notice that there are API changes which are not backward compatible, and these leads to errors and exception. The responsibility, the person who's designing this framework, he should take care of capturing such exceptions and maybe bundling them and then giving it back to backend servers. And this will, the reason I'm saying this is that it will give an insight to all the iOS and Android teams that I have, and it will tell them exactly what kind of issues their users are facing.
Fair enough. Fair enough. So perhaps using this information, I mean, I will be able to, I think, narrow down whether the problem is on the client side or whether the problem is on the server side. But I mean, currently, as we said, that we are not going to be discussing about the client side issues right now or the infrastructure issues. We will cover them perhaps in some of the other sessions. So let us just say that it is not a client side issue right now. Okay, so I mean, I have identified that it is a server side issue. Now, what I think I will do is that I will start checking I will start monitoring the dashboards, right, to see if the HTTP responses that our website is producing are those mostly 2xx responses, right? So the 200 responses basically that the responses are succeeding. We're not getting server errors from our side, right? Similarly, if the number of 5xx errors on our system is more than a particular threshold, then what we could do is we could raise an alarm, right? That would alert the team and whoever engineer is on the all call duty. So basically, something like, so imagine if you have if you are working for a large company, then usually whenever a system is live, whenever something critical is happening, something like a cricket match is being streamed, or something like on Flipkart, there's a big billion day going on, then there will be a couple of engineers who will be on call. Their responsibility will be to take care of production issues as and when they occur. Right. So let us suppose that, I mean, what we could do is based on the error thresholds, we could raise an alert and basically get the on-call engineers to respond to it. How does that sound?
It sounds really awesome. You've raised really good points, Pragya. I'll talk about each of them one by one, right? So first point that you raised was around monitoring dashboard, right? Basically keeping an eye on the number of, or basically a percentage of requests that are failing. And we can define a threshold which can be different for each and every system, right? For example, if you're using Google search, the threshold of number of requests that can fail will be very, very low, right? The uptime or the kind of guarantees that Google provide is that their systems are able to respond to 99.999% of the times. But if we compare it with other system like payment system, for example, this number of failing requests is a frequent scenario in such kind of systems. The industry standard for payments getting succeeded is around 70%. They make it to 90%. They go to 90% by having multiple other mechanisms like retries and retries with exponential backoff to make it more reliable. But 70% is basically the industry average. And just by measuring the number of requests that are failing, that will not give me a very good insight as well. What we should typically do is we should also look at how much time each of how much time my 2xx request is taking. This is usually called the latency of application server. How much time does my application server take to, first of all, accept a request, do all the processing and computing that is required to answer this query, and finally respond it back to the server. The total time in this process is basically called the latency of the system, of the application server. And the reason I'm stressing on the latency part is uh, whenever you're designing system, the latency also measure is also quite important. For example, if you're designing a Google search, type ahead, and if that suggestion that comes up, right, when you type Michael, it shows Michael Jordan and bunch of other suggestions as well, right? If you type Donald, it might suggest you Donald Trump or maybe Donald Duck. Uh, but the essence of this is basically that these suggestions are only meaningful if the latency of such systems is very low. If it takes 5 minutes to, or sorry, 5 seconds to show up these results, it's quite pointless. However, if there is a banking transaction, or maybe you are generating movie recommendations for users who have just signed up on Netflix for the first time, 5 seconds over there is still bearable. You can still bear 5 seconds. They'll wait for the 5 seconds. And hence, I'm saying it again, measuring this time and setting a proper threshold is not only important, but is also use case dependent, right? So this was
Fair.
basically the first point that you spoke about monitoring. Let me give an idea about the second point that you pointed out, which was around alerting, right? So you said that if there is a threshold reach, we'll raise an alert, and that might go to a on-call person, right? But the question is, should we is it fair to wake up a real person post midnight, even if he encountered just one violation of latency?
Hmm. Fair enough.
The
That
answer,
would be good. Oh,
yeah. So I think that's a rhetorical question. The answer for the question is basically no. It does not make sense to do that, and it does not make sense to do raise an alert for every every sort of exception that we are getting. So we should have basically varying levels of severity, because I don't want to disturb the developers who are in a case where I'm getting huge number of 4xx, which are basically client errors. Maybe the client itself is sending me a bad request. They're calling a get API, but in the HTTP method, they're writing a post API. In that case, I don't want to alert my developer. So it also depends upon whether the alert that I'm getting is worthy of waking up a person or not. So it should have basically varying level of severity. But I won't want to hear your suggestions on what should be the criteria for raising an alert in case of specifically in case of latencies.
fair enough. Fair enough. So, what we can do is, since we don't want to overwhelm the person on call, what we could do is we could raise an alert only if the average latency of, let's say, 5 minutes, the past 5 minutes, if that average latency goes beyond a threshold, only then we will raise the alert. How does that
Uh,
sound?
so you are in the right direction, but not quite there. So I'll tell you where you are right. So the idea where you said that I'll use a certain time period for analysis, that is actually correct, right? It makes sense to observe the system behavior for a given period of time, but it does not make sense to use average as a metric, right? The reason I'll come to the reason uh, in a bit, but before that, I would like to highlight over here that you should almost never rely on average metrics when it comes to raising alerts. Instead, what you can rely on is a metric called P99. In simple words, this P99 metric that I'm calling out is that 99% of my requests that are coming to my system will take less time than the time that is reported on against this P99 metric on your dashboard. That means that 99% requests which are reaching my system will, for example, if the time is let's say P99 is written as 10 milliseconds on your dashboard. That means that 99% of my request will take less than 10 milliseconds. Let me give you an analogy to explain you why average matrices don't work. So the pleasant temperature for a normal human being is, let's say, 25 degrees. Now imagine if I place your head in minus 10 degrees and your feet in 60 degrees. The average temperature is still 25 degrees, right? But it's not a very pleasant experience, and most likely the person will die as well. Similarly, in software engineering, measuring the 99 percentile metrics of P99 are more important as compared to the average metrics. And this is true for any kind of a metric, not just latency, right? We look at other metrics that are quite important. So, Pragya, would you like to talk about some of the metrics that are important?
So, if I'm looking at the P99 statistic, what I would like to measure is, first of all, the latency of all the APIs that we have in our system. Right. Apart from that, I would like to measure some things about the load on our servers. Right. So, I would like to measure how much disk space is remaining on our servers. Right. What is the RAM availability? How much CPU load are they facing? Right. So, basically, I mean, based on these metrics, what I will be able to do is I will be able to decide if I want to launch more servers, if I want to scale out, basically, right? If I want to add or remove instances. And basically what we could also have is, based on these metrics, we could have some sort of a pipeline, we could have some sort of a hook that will auto scale our servers. So if the demand suddenly rushes in and we don't even have a person on call, then the software automatically will detect that, hey, the CPU load is going higher, so it will automatically launch more instances of the application. So latency of APIs, server stats, that is something that I would like to measure. Apart from that, I think at the code level, I would also like to measure the time each function is taking, right? So that would really help me narrow down at a function level, right? Basically, where the issue is happening. So it could be the case that basically the call to a particular function is taking very, very long. So if I track the times for each function call, then that will help me pinpoint the issue accurately, right? But I mean, I will have to be kind of cognizant of monitoring the latencies of functions that are involving some sort of IO call, right? So it could be the case that a function is basically making a server request, right? So I mean, I want to measure the latency of functions which are making server requests. But if the function is very simple, right? If the function is as simple as, let's say, add something, then I don't really want to measure the latency of that. So if the function is complicated enough, I would want to measure the time that function is also taking.
So with time, our approach should be that we've started measuring the function latencies. But if, let's say, this code becomes a legacy code and this has been running for like ages now, we should omit the measuring latency part, because that also has an overhead attached to it, right? Because measuring latency, the way it happens is that when a call comes to a function, the time stamp of that particular that particular timestamp is noted, and whenever the scope of that function finishes, that timestamp is noted, and then difference is calculated, and it is basically logged out to either a log, or it is flushed out to a channel where this latency is basically calculated. So you are wasting three instructions while measuring the latency. So if you have a function like add two numbers, I would rather not measure that particular latency, because I know that this is a simple enough instruction. It does not make sense to add the latency measuring the latency overhead in this case. And I'll also like to point out some other parameters that I would like to monitor. Right, I would also want to monitor the amount of how is my heap memory looking at a given point, and how are my GC cycles happening. Right, we all know that most of the programming languages, unless you are writing code in C or C++, comes up with the concept of heap, and they also have a garbage collector which collects the objects heap, right? Frees up the space for newer objects. Monitoring these will give you deeper insights on how objects are basically piled up in the heap, and it may also point out possible memory leaks that are there in your application. How you are going to find out that there are memory leaks? You can just look at the graph of heap memory, right? It will be in a form of a mountain, then a valley, then basically down, peak and down, peak and down. That downward is basically when the GC starts triggering it. So just by measuring this, just by monitoring your heap memory, also you can find deeper insights into your application, and inform your developers that hey, this is maybe there are some memory leaks in your application. The second one is the second metric that I would want to add is basically keeping an eye on the number of active threads or connection that my application is making. This will give insights if we can parallelize tasks in the applications or not. And the last point that I want to add is around file descriptors. Uh, I don't know if you know about file descriptors or not, but file descriptors are basically opened whenever you open up a file on the OS, right? You might have seen. So just go back and do this experiment in any programming language. Open a file, write a for loop, open up and in that for loop, it should be an infinite for loop. Don't do anything, just do uh, try opening files in that particular for loop. Eventually there is a limit on the number of files that can be opened in an OS operating system, and that limit will be hit and you'll get an error. So there are systems which are basically based on the file descriptors as well, right? For example, Kafka. If the number of file descriptors are quickly increasing, and they are on its way to eat up all the file descriptors that can be basically the OS limit, then it does make sense to raise an alarm to the platform team and alert them that hey, this is the kind of issue that we are fixing. You might want to do something about this particular issue, right? And using these metrics, we can decide around allocating or removing resources that Pragya has already spoken about. We can scale in or scale out depending upon the load. Uh, all of this will basically help me in automated addition of resource or automated removal of resource behind the load balancer. Right? If you have worked on AWS, you will get to know that these are the kind of this auto scaling thing that me and Pragya are basically saying it again and again, will come up, is basically a service that is offered by AWS, and these are the standard parameters on based on which you can increase the number of resources.
Cool, cool, cool. That makes a lot of sense. But coming back to the topic, maybe the issue is still not solved. So using these metrics and basically using all these charts and monitoring things, maybe I've figured out what the exact problematic API is, and maybe I have even narrowed it down to a particular function. Right? But I might still not know what the exact issue is. So I am thinking that now is the right time to start looking at the logs, right, and see if we can find something over there. So what I would want to do is I would try to basically look at what servers we have. I would assess it into one of those servers, right? So I'll just open my terminal. I'll open something like iTerm. I'll assess it into my server. I'll navigate to wherever the logs is located, and I'll just tail that log, right? I'll try to read the last few lines of that log to see if I can find what the exact issue is. So I mean, what does that sound like?
Yeah, so if we have multiple, let's say I just have 3-4 servers, so I can use the item window itself to basically broadcast input to multiple servers, and I'll primarily, if I want to just check whether there are exceptions or not, I can also grep for that particular exception keyword into into the logs, right? But this approach also will not scale, right? Typically, in any company of a decent size or decent volume, those companies have like hundreds and thousands of servers. It is impossible to SSH into each server. So what
Right.
you can do is you can ask each server to basically direct the logs into a centralized location. Now this centralized location is basically responsible for storing logs from all the services that are there in the ecosystem. So, for example, in AWS, there might be, for example, in Amazon, there might be a service corresponding to order management. There will be a service which will be responsible for inventory management, for example. We'll collate logs from all these services, different services, and put it into one place. The benefit that we get out of it is that once we have all the logs from all the services in one place, we can throw all these logs into a system like Elasticsearch, and we can write queries and the same grep command that you are doing on while SSHing into a particular instance. We can do it at a centralized location. I don't have to, go into thousands of VMs and find out whether there was an exception or not. But there is still one more problem with this, right? And this problem is not at a log. How do I go into the log and find it out? This is more of a logical problem, right? To give you a glimpse of what this problem is, just imagine how a particular API is written, right? Whenever an API is written, or to write a API, typical uh, typical structuring of your code is like that you start from a controller. So your controller is where your APIs are basically defined. From the controller, the request goes to a handler. From the handler, the request will go to a service. From the service, the request will go to a database layer, fetch something, and then return back. Or it might be a case that a service calls another dependent service, which might be a uh, different system altogether, right? An exception can occur in any of the layers that I've just described. Each layer might have different functions, right? The the crux of the problem that I'm getting to is that exception can occur in any of the functions, right? And the entire context of the request lies in the controller. How do I pass this context, the complete context which was there in the controller, to the function in which the exception occurred? One way to do that is that I pass the exact request params that are passed during my API call to every function, right? I can create an object of everything that is there in my application, like everything that was passed to my API controller. Pass this particular object to each function that is responsible for processing this particular request. But this is far from ideal, right? What if each layer is developed by a different set of teams or different developers? How do I avoid manual errors? Let's say I forget to pass this outside of my service, and the exception was occurring in the database layer. Now, if I forget passing this particular, request to any of the functions, the subsequent function calls will not have context about the exact request that was there. So, can we do better than this? A slightly better way to do this is generate a unique ID as soon as I get a request and pass this unique ID in all the functions. This way, I'm not passing the entire big request object. I'm just passing a string. Maybe I can generate a UUID out of it, and I'm just passing a UUID. However, even this approach is prone to manual errors, right? So, a common practice to avoid this kind of a thing is, uh, and this is where this basically works because we want everybody to each function basically to follow this kind of a practice that while logging, I'm logging this particular unique ID that I generated in the beginning of the API call. So there is a chance to externalize this responsibility to a framework. In Java world, it is called AOP, aspect-oriented programming. I don't know if you guys have heard about it. This is called aspect-oriented programming, where this aspect will be attached to each and every function, and the responsibility of this aspect is to pass on the unique ID that was first generated. Right? There are many logging frameworks that has this kind of a functionality inbuilt. Right? Uh, so using this approach, I've solved for the problem of issues arising within that particular application server. But in reality, to process a particular request, we might end up calling multiple services. For example, to render the homepage of Amazon, we might need to render promoted links, like we might want to promote item like OnePlus, maybe a new iPhone that is getting launched, and we also need to show recommended content based on the user's previous order history. So if a service A calls service B, we need a system that will help me trace the request not just in service A, but also help me in identifying the same request when it goes to system B as well. This kind of a mechanism, which will help me trace requests from one system to another, is basically achieved by something called as a distributed log tracing frameworks. Right? There are uh, frameworks like Sleuth available, which will give you the exact functionality that I've just spoken about. And the way this works is, you might be wondering how would the request, how would I pass the ID which is generated in service A to service B? The way it is done is that a I attach this unique ID into the HTTP header. So whenever service A calls service B, it will attach this unique ID in the HTTP headers. Service B will read this HTTP header around the logs. This is called spans. Will read this particular uh, will read this particular ID and print it the same way service A was printing it. Right. So this is all you need to do to trace an exception that originated from service A and ended in service B, right? So we've touched upon multiple, just in a very, very short time. I'll open up for questions now. If you have any questions around this, uh, please feel free to ask them now.
Right, so over to you guys, the audience. If you have any
Over
questions, put that, and we'll be taking those questions. Okay. Cool. So I did see a question pop up on the screen just now, but the question is gone. Yeah. So
is there, uh, is these stats depend upon platform we use like Node.js or Spring Boot, or which one is better in production? So I've massively worked on Spring Boot. Spring Boot have an open source library of cloud utilities, right? We have Sleuth, which works particularly for Java based Spring Boot applications. But there are open source equivalents as well, right? Which are basically polyglot in nature. So in those cases, it does not matter whether your service A is written in Java or service B is written in Python. Like, it does not matter which language you're using, it will work. People have come up with standards that, hey, for sending this log to the next application, this should be the header name, and all the applications and all the client libraries are built using those standard semantics.
also, Mohit, I think Rahul's question is a little bit came a little bit earlier. I think he's asking about the statistics, what the server statistics that we are measuring. So you told
Right.
me that we have to measure things like the number of CPU threads that are running, the file descriptors, and I myself wanted to measure the function latencies and API latencies and stuff. So I think Rahul is asking about that. So could you touch upon that, perhaps?
So yes, so I think it makes sense for Node.js application also. At the end of the day, all the application need system resources, right? We need all the application servers will need matrices to rely on. Like latency is polyglot, right? By the way, polyglot is that your application or your entire ecosystem of applications that you've built is written in multiple using multiple languages. So these latencies and matrices that we spoke about are basically not language dependent, and all the high level languages that are there right now are basically taking care of are basically taking care of the memory by themselves. So in one way or the other, they will need to clear out the garbage that is basically collecting. Memory management is done by those languages. So yes, it helps in measuring those. The short answer is yes, it helps to measure this irrespective of what language you're coming from.
Perfect, perfect.
I hope I answered your question, Rahul. We'll go to the next question. Cool.
So, which are the tools used for monitoring thread dumps, heap spaces, and other metrics? So, yes, Mohit, could you say something
Cool.
about this?
I'll take this up. So there are multiple tools, both open source like there are. If you are looking for open source framework, there's JProfiler which you can attach in your one of the servers that is running, which will give you a very detailed view of what all things are happening inside your heap memory. It will just give you a throw of a heap dump. For example, if the heap size is 4 GB, it will throw up a 4 GB heap dump, and you can use some JProfiler to analyze what exactly which object is taking the most amount of memory in your heap to offer other matrices that we spoke about, like latency and all that. Uh, that open source version is you can use Grafana or Graphite to basically push out the matrices, and you can use Graphite for plotting out the graphs. The paid version, however, is basically you can use New Relic. There are Datadog. There's a company called Datadog. Uh, those are basically simpler to set up as long as you're like willing to pay them a hefty amount. You can use them. Otherwise, you can go for the open source variants.
Cool. So, I think we can move on to the next question. Yes.
Can you provide an example of file descriptors? Okay. Can you provide an example of a file descriptor? So I told you, right? In Kafka, so the way Kafka stores its messages is that uh, I have to give some context about Kafka here. That's what I was thinking. So the way Kafka stores its messages is it opens up a file. That file corresponds to a partition, and partition corresponds to a topic. So at the end of the day, all the messages that are coming to Kafka are basically stored in file. And whenever you have to write a particular message to a file, that will be to write a message to a file, you will have to first open a file and then write a message, and then only you will be able to close it. Now, let's suppose the number of partitions are huge. You've created, like I'll digress from the current topic if I go into detail, but let's suppose to achieve scalability, what you did was you created multiple partitions of that particular topic. That will end up creating multiple files on the operating systems. And if you start writing to all the topics at one, or all the partitions at a single time, you will face problems like of file descriptors exhausting out. I hope that answers your questions, G. How to debug an issue where a set of users are experiencing slowness in global app like Amazon and Netflix? Ratnesh, that is a excellent question, and that comes under the purview of infrastructure piece that we are not covering today. A short answer for that is it might be due to DNS which is getting misconfigured. It is very much possible that, let's say, I am sitting in India, and in the DNS resolution step, what happened was that I was returned an IP address of, let's say, US, right? So that will inherently add a latency of 200 milliseconds because India and US are geographically quite distant from each other. So that's a short answer. We'll do a separate session on the similar lines where we'll dig deeper into the infrastructure issues as well, and client side issues also, right? For example, if I talk about just one line of about client side, it is very much possible that the stream that I'm sending to the my client is not compressed. If that is the case, then it will experience a lot of slowness. So those are some kind of client issues. So we'll do a session on both of these in future. Don't worry. Any other questions, guys?
Cool. So, I see this one nice question from Jeet. Jeet is asking the following. Can you take this up, perhaps?
Yes. Can you give some tips on how the on-call support engineer should start debugging? Like, should he start from in from exit or he first? Okay, that's a great question. Let me sum. This will basically give us a chance to summarize our discussion as well, right? So the first thing is identify whether it is a server-side issue, infra-side issue, or is it a backend issue. How you are going to identify that? If the problem is coming to you, chances are it will be a backend issue. That's why we did this problem, right? The way to negate a infra side issue is monitor on your load balancer. So if you're deployed your application on AWS, AWS load balancer will give you a metric about how many 4xx and 5xx and 2xx are there. If the number of 5xx are alarmingly high, chances are it's a backend issue, right? AWS also gives you a way to monitor how much time each request is taking. So if the latency of a system is going for a toss, that means it's again a backend issue. Uh, Using this, you just have identified that hey, this is the backend issue, right? Then you drill down which API is causing this kind of a problem. Again, the friend over here is your monitoring dashboard. Have a like monitoring setup. The way you set up monitoring is either you can go for open source versions where you measure the latency of every API, or you go for a paid version which will do it out of the box for you, right? After you have identified which API is causing the issue, you drill down into that API by using the logs that you are getting logs that you're connecting, right? So using this, you'll basically narrow down the problem to exact issue that you have, exact issue that is basically coming up.
Cool. So I think this is another interesting question that we have.
How do you debug issues when a cluster is running in different regions? So simple answer is that monitoring dashboard will basically define where exactly your application servers are running and which application servers are performing different tasks. So typically, how you set up monitoring in those cases is you have different dashboards for different regions. So have a collated view. So I did this in Hotstar as well, which was live in US and India at that time. So we had a separate counter and separate latency metrics for US and a separate latency metrics for. I'm just using latency, but there were a bunch of other matrices as well. We spoke about them in the past, and a bunch of matrices in India data center. The reason we set up a different monitoring on both of them is because the data center, inherent data center, which is serving Indian users and US users, are different, and that's the reason we like both of them will have issues, will report issues separately. Right? It's just that Hotstar.com for US users will resolve to US data center, and Hotstar.com for Indian users will be resolved to India data center.
Perfect, perfect. This seems like a really interesting question. Chahat has a question about low load services.
Appropriate one error out of four may result in. Cool. Uh, I will give you a very good analogy for this, right? I'll give you a good example where such kind of systems will occur, right? So, assume you're building a Netflix ingestion pipeline. Okay. Ingestion. What a ingestion pipeline means? That let's suppose Netflix comes up with a new show and it wants to air a new episode in that particular series. So that is actually a very time consuming task as well, right? Typically it will take uh, hours for a person to upload it and take it live to the end audience. The reason is that it will go to multiple quality checks, both manual and automated. There'll be checks in the frame as well. So the kind of TPS on these kind of systems is very low, and even if one request fails in such kind of scenario, even if one request fails, that means there is a huge amount of customer base which will get impacted. So I should definitely raise an alarm in case there is even a one failure. To avoid waking my on-call engineer on the night, what I can do is, if this is not a fire, depending upon the feature, right? Let's suppose The video that I'm trying to ingest in the Netflix system has to go live next week. I still have time. I will raise an alarm. I will send an alert, but the actual call to the person will go in the morning during the office hours. So those things are. I'll basically change my alerting mechanism, not my monitoring system. Monitoring system still remains intact.
Cool, cool, cool. That makes sense. Ankit is asking, can you talk about some tools that you can use to automate the alerts?
Right, right. So one of the just explore elastic stack, okay, for all these kind of questions, for monitoring, for logging, for distributed tracing, for alerting. Use the elk stack. That stands for Elasticsearch, Logstash, Kibana. Kibana, the newer version of Kibana especially has a capability to send alerts as well. For doing an on-call kind of a duty, if you want to manage who is, let's say there are 6 developers in the team, there's one developer from the team takes care of the entire infrastructure for 1 week, and then you rotate among the people who are there. So for doing this specifically, there is a tool called PagerDuty. It's a paid tool that you can use. With PagerDuty, you would be able to call the person, send an SMS, send a pager alert, and do bunch of other tasks as well.
Interesting, interesting. Cool. Jeet has a question about that his company is using P70 matrix instead of P99 matrix. So
Wow.
could you talk something about that?
That's a very so I would say that P70 will not give you good insights. I think maybe the reason why your company is using a P70 kind of a metric is uh, the SLAs are basically defined that way. So typically, when you have enterprise contracts, right, you have to define how much would be your P99, P70, or P50. There's a P50 as well. So it starts from P50, P70. 70 is the first time that I'm hearing it. P50 is there, P75 is there, 95 is there, 99 is there, and 99.9 is there. And usually, when you have a service level agreement for between enterprises, you have to specify that what would be the threshold or the max limit for these metrics, right? So maybe the project that you were working on, the contract was that 70% of my request will, I'll basically please 70% of the customers. But as an engineer, your goal should be to look at P99, or maybe if you are a rockstar engineer, then look at P99.99. You can add as many nines as you want.
Cool, cool. Ratnesh has a really interesting question. Ratnesh is saying that debugging is good, but we should try to avoid the problem in the first place. So, when we are writing the code, what can we do so that debugging becomes a lesser hassle and we
Right.
can do debugging really fast?
Yes. So if you remember the first thing that I told you, right? If you're an application developer, for example, Android app developer, the exceptions are occurring on the mobile devices and not at the server. So whatever exceptions are occurring on the mobile devices, you won't get a chance to know about them. That's the reason it becomes essential that as soon as an exception is occurred, you log it in the system memory, Android device, right? And from that Android storage, once a person is connected to internet again, send that error report to the backend people, so that they can go and debug that particular application. Uh, for others, right? For backend systems, having a so typically how people do it is, as soon as they get an exception, they keep a monitor on their logs. As soon as they get an exception, or maybe you would have written try catch block if you're a Java developer, right? In the catch block, just put that exception into a queue, right? People call it a dead letter queue. Put that exception into a queue, and there is a special person who can look into what are the exceptions, what are the most common exceptions that are occurring, and you can look into that. Paid solutions for logging exceptions and doing all these exception analytics is Sentry and Crashlytics. I think they have they also have an open source variant or a community edition. I'm not sure about that. Just go and have a look at whether they are providing a community edition. but paid solutions are already there.
Cool, that is interesting. I am not seeing any more questions in the chat as of now. So, guys, if you have any more questions, please keep them coming.
Yeah,
Okay. So we'll just
you
wait
can
for a couple of minutes. To
or what you can do is you can even after the session is ended, put your question in the comment, right? That will help us. We'll keep we keep on looking at the comments, and we'll reply back if you have any questions. Also, I would request everyone to please comment about specific areas that you liked about the video. That gives us encouragement and motivation about doing such sessions in the future as well. And please like, comment, and share and subscribe to our channel. Grow and spread this word. This is a free initiative that we have recently started, where we will help in helping each and every engineer um, grow and upskill themselves. So please do like, comment, and share and subscribe to our channel. Yeah.
cool, cool.
How to Sunil has a question. I'll take this as a last question. How to handle garbage collection in time of multiple ticks or threads? So garbage collections are specifically for Java. You have special collectors that you can have. You can configure the kind of collector that is running. There is G1 GC, there is serial collector, there is parallel GC, there is concurrent mark and sweep. So multiple algorithms are there for garbage collection. For others as well, I think Pragya can talk about if you want to talk about some how does GC works in Python, and if you can configure a garbage collection algorithm.
Right. So I'm not sure. Python does allow you to hook into the GC. So I think the library for these are inbuilt libraries in Python, which is literally called GC, right? And you can basically hook into it to figure out when an object is being garbage collected. I think you can plug and play different algorithms in there as well, but I'm not exactly sure. You will have to check that library. But if you look at any sort of programming language that is used for web services and that has some sort of a garbage collector, you will be able to that programming language will definitely support a library to hook into garbage collector and basically try to configure. You can try to configure basically when the garbage collection happens or what algorithm the garbage collection use. You can basically tweak that those things. Does that make sense? I'm not sure if that answers your question. So your question is more specifically how to handle garbage collection in time of multiple pings or threads. Is that your question? Multiple pings or threads?
I think it's multiple things. Okay. So you cannot control garbage collection. You cannot say to the garbage collection that start collecting the garbage now. You can, however, hint it, and it depends upon the algorithm that you're using. It might honor your request or it might reject your request as well. So there's nothing special that you can do in terms of that I want to collect the garbage now. That is not possible, even in
So one
Java.
thing that you have to take care of from a design perspective is that you have to look at how your application is managing the objects. In case your objects are forming a very large graph, right? If they're forming a large cyclic graph of objects that are dependent on just one variable, right? So imagine that there is one variable that is talking to an object that is basically referring to an object, and that object in turn is referring to an entire tree or an entire graph of objects. Now, if this variable goes out of scope, what will happen is the garbage collector will kick in very late to clear up this entire graph. Right? So you should try to make your design in such a manner that this thing does not happen. Does that make sense? So that is something that you can do. Now, of course, for garbage collection, there's a lot of other things that you can do. So perhaps what we can do is we can have a separate session on that sometime on the
I
same
think
channel.
there are multiple people who are requesting for a session on garbage collection. So we'll probably plan a session alongside after we are done with infrastructure and client. We'll probably plan a session around garbage collection as well. Cool. Keep the interesting suggestions. When if you have any suggestions around what topic we need to do, please comment that topic name. Just the topic name in the comment. We'll make sure that we do a session on that particular topic. All right. I hope the session was informative and interesting for you. and I'll hope to see everyone in the next session as well. Thank
Perfect.
you
So,
so much.
one more thing that I would like to mention, Mohit. So, apart from this particular session, in this junior developer versus senior developer theme that we are having, what other future videos are we expecting to see? Can you comment something about upon that?
So we'll have a video. So next we are planning to have is a session on. Uh, so this was basically a tech-oriented session, right? And technical skills is not the only thing that is required to climb up the ladder. So we are planning to have a session on soft skills. You won't believe the differentiating criteria between my interview at Facebook uh, was basically on the soft skills aspect, right? So they say that the technical interviews are basically a filter criteria, and whether you'll be offered a position as SD3 or SD2 depends upon how you portray yourself in the team and how do you manage team, right? Manage your team. So we are planning to have a session on soft skills specifically, probably next time. And we're also again we missed out on the client and infrastructure side, so we'll also have a session on that. We'll have sessions on how do you develop a app, like roadmap series kind of a session. How do you develop an app from start to the end? So those are the things that are there in the pipeline. Hope to
Perfect, perfect. That
see
sounds
you
interesting.
in this.
So, as we said, guys, keep the questions coming. Basically, we will be ending the session, but we'll be monitoring the comments that you are posting, and basically, if you have an interesting question, we'll be replying to that. All right.
Yeah.
So that is it for this session. Hope to see you guys in the next session. All right. There are
Yeah.
many more to do. So see you then. All right. Bye bye.
Bye bye.